Hello everyone, welcome to Max's channel. If you're into learning physics in fun and creative way, then you are in a perfect place. Have you ever wondered how to figure out the direction of something's moving when different forces and motions are pulling in different directions? Then, that is where the resultant vectors comes in. In this video, we're going to break down the resultant vectors, what they are, how they work, and most importantly, how to calculate them like a pro. Whether you're dealing with forces, velocities, and any other forms of vectors, mastering this will make your physics life much better. And don't worry, I've got some tips, tricks, and examples to make this fun and easy. So grab your notebooks, scientific calculators, and maybe some snacks, and let's get into it.
But first, let's talk about the resultant vector. But what is a resultant vector? Resultant vector in physics is the single vector that represents the combined effect of two or more vectors. It's the equivalent vector that would have the same overall effect of applying all the individual vectors at once. When we add vectors, the resultant shows the total force, displacement, or velocity that results from combining these vectors. To put it simply, if you're pushing an object in two different directions, the resultant vector is the direction and the force the object actually moves, as if there was just one push. There are two ways in how to find the resultant vector. First is the graphical method. Graphical method involves drawing the vector to scale and measuring manually the resultant. Next is the analytical method. This method uses calculations to find the exact value of the resultant vector. So let's try these ways. We have here the problem. And the question states what is the combined force for the resultant and its direction. So let's try this one using the graphical method. In this method, you just have to plot the given data properly and measure the tail of the first vector and the head of the last vector. From the given data, Marian, the first vector, pushes the box at 4 newtons to east. The head of the first vector will become the tail for your second vector. Remember that. Next, let's plot the other data. Isle, the second vector, pushes the box at 5 newtons at 40 degrees north of east. Take note, in measuring the angle, do not forget to use a protractor to get the exact data. Next, Justin, the third vector, pushes the box at 7 newton to south. Antonio, the fourth vector, pushes the box at 2 newtons to north of west. And lastly, Afia, the fifth vector, pushes the box at 3 newtons to south of west. With the given data, we came up with this graph. From here, we just have to connect the tail of the first vector and the head of the last vector, then measure it. I saw this one on a real paper where 1 newton is equals to 1 cm, and that's why I get 7.6 newtons. Also, I measured the angle and I get 47.9 degrees. For the direction, let's get back to the Cartesian plane where the quadrants are placed. Quadrant 1 is equal to the north of east, quadrant 2 north of west, quadrant 3 south of west, and quadrant 4's south of east. Since the resultant vector is found in the quadrant 4, therefore, the direction is in the south of east. How about if we try finding the resultant vector using the analytical method? In this method, you are more likely getting more accurate answer. You won't need to graph anymore, but you are gonna solve something, so get ready and get your scientific calculator now. We're going to have the same problem but different ways in answering. So first, let's put the given data in a table. If you have noticed, there are primary directions used in here, right? There is no angle given, so what should you write? The answer is here. If the direction is in the east or west, you should use 0 degrees. But if the direction is in north or south, you should use 90 degrees. So here the first vector is going east, and east means 0 degrees, so that is 0 degrees. The second vector, that's 40 degrees. The third vector is going south, and south means 90 degrees. The fourth vector is 30 degrees, and the fifth vector is 70 degrees. In finding the resultant vector, you will going to use this formula. But where are you going to get the x and the y values? The answer is simple. Let's calculate. For the x and y values, use this formula. X is equal to r cosine theta and y equals r sine theta. But first, let's get the signs first. For the first vector, it lies on the x-axis, so the y-axis is automatically equal to 0. Same as the third vector, which lies on the y-axis, so the x-axis is 0. Let's get back to the first vector. The first vector is going to east, and east means positive in x-axis, so this is positive. The second vector is in the direction of north of east, and north of east is in quadrant 1. That's why both x and y axes are positive. The third vector is going south, and south means negative in y axis, so this is negative. The fourth vector is in the direction of north of west, and north of west is in the quadrant 2. That means the x-axis is negative and the y-axis is positive. The fifth vector is in the direction of the south of west, and south of west is in quadrant 3. That's why both x and y-axis are both negative. So in solving the x and the y components, use these formulas. X equals r cosine theta and y equals r sine theta. Here are the following list. After completing the table, add all the components of x and y to get its summation. For summation of x, that is 4 plus 3.83 minus 1.73 minus 1.03, and that is equals to summation of x equals 5.07. For summation of y, that is 0 plus 3.21 minus 7 plus 1 minus 2.82 equals summation of y is equal to negative 5.61. After getting the summation of x and y, let's plug in the values in this formula. resultant vector is equals to square root of summation of x squared plus summation of y squared. While using this formula, we can get the resultant vector, and that is 7.56 newtons. Next, make use of this formula to solve for the angle. Angle theta is equals to inverse tangent of summation of y over summation of x. Then solve. While using this formula, you can get angle theta is equals to negative 47.89. But since there is no negative angle, let's get absolute value of this one, and that is 47.89. And lastly, let's find the direction. Since we have the angle now, let's find its direction. But how? Let's get back to the summation of x and the summation of y. As you can see here, the summation of x is positive and the summation of y is negative, right? Now, on what quadrant does the x value is positive and the y is negative? That's right, it is on the fourth quadrant. So, the direction of this is south of east. So, here are the following answers when we use the graphical method and the analytical method. But haven't you noticed that the answers are likely similar? When we use the graphical method, we get resultant vector is equals to 7.6 newtons at 47.9 degrees south of east. And when we use the analytical method, we get the resultant vector is equals to 7.56 newtons at 47.89 degrees south of east. Since they are most likely equal, this means that what I have done is correct. By following these steps, you can either visually or calculate the resultant vector. The graphical method provides a visual understanding and is useful for estimating, while the analytical method is precise and ideal when you need the exact values.